Hello everybody and welcome to part 10 of our NLTK with Python for Natural Language Processing tutorial video. In this video we're going to be talking about WordNet. So WordNet is probably one of the largest, not really corpus, but the largest, I suppose, capability corpora that you're going to be given with NLTK. So with WordNet what you can do is you can take words and you can look up synonyms to words and antonyms and definitions and then even context of that word. So let's go ahead and just dive in because there's a bunch of stuff to do. So first we're going to do from nltk.corpus we're going to import WordNet. Now this import takes a few seconds depending on your computer, so just be patient with it. Then let's say we want some synonyms or synsets basically. So syns equals WordNet.synsets, and then you can put in the word here. Let's use the word program because program actually has a lot of meanings. It could mean a lot of things. So we'll do that, and let's go ahead and just print syns. Okay, so here we have some synsets or synset. Yeah, synsets. So it's just a list, right? It's a list of these synsets. And you'll see later on that we can end up using this right here as a search parameter down the line. Anyway, so you can see that for program we have things like plan, program, broadcast, and that's because program has many different meanings. So you can see we actually have quite a few program nouns. But plan, broadcast, course of study, that's the only other ones that I see. But anyways, those are synsets, and then obviously since it's a list you could reference an element in that list. So you could say the 0th element. Now we can also get, say we want like maybe just the word, so we could do something like this. So we could say print syns 0.lemmas. Well, first we should probably, we can do let's do .lemmas. So let's see what that gives us first. So we want the 0th element, but right. So some lemmas for this are like plan, and plan, with a special spelling of programma. Anyway, lemmas 0 and then .name, like that. So you can get just plan, and then if may or may not be able to actually get away with doing .name here as well. Let's try that. Right. So here the problem is you're getting like the whole synset. The synset.name is this, not this, whereas the name for the lemma is going to be just that, like an actual word. So anyways, there's that. Synset, just the word, just for some notation there. Now let's take it a little further and do like a definition. So we can print syns 0.definition, empty params. And this will give us the definition for the specific word that we're looking at. So this one is for plan. It's a series of steps to be carried out or goals to be accomplished. Okay, that makes sense. So then what we can do is we can also do examples. So like I was saying before, in context. So we could do syns 0.examples. Save and run that. Let me pull this up a little bit. They drew up a 6-step plan. They discussed plans for a new bond issue. Okay, so that makes sense. So now we could do this for any of the elements in the list. But then, what if we wanted to have synonyms and antonyms? Well, we can. I guess we'll leave this stuff here. It's okay, because I always post the source code. But if you want, you can delete this stuff, and it'll kind of make some space for you. But I'm going to do this. So now we're going to say synonyms equals an empty list, antonyms equals an empty list, and then we're going to say for syn in WordNet.synsets, and we're going to use the word good since it has good synonyms and antonyms. For syn in WordNet.synSet's good, and then we're going to say for L for lemma in syn.lemmas. What do we want to do here? Well, we're going to say synonyms dot append L dot name, because again, lemmas, if you remember, are like synonyms, so we're just going to treat them like synonyms. And then if there are any L dot antonyms, whoops, that'll be empty parms there. We're going to say antonyms dot append L dot antonyms, empty parameters, element 0 dot name. Okay, so L antonyms 0, so that should kind of be like right here, basically lemmas 0 dot name. We'll print out a little bit more at a time after we run through this one time, so you can see what each step of the way is doing. But for now, let's go ahead and print set synonyms, and let's print the set of antonyms, and let's fix print in a moment. Antonyms, print, save and run that. Drink some coffee. Okay. Okay, so we have synonyms, which is, these are synonyms, so thoroughly, full, skillful, well, beneficial, trade good. So obviously this is a synonym for literally the term good, as in goods or services. So trade good, secure, safe, okay. All this stuff, synonyms to good. Then you have antonyms to good. Evilness, ill, bad, evil, badness. Okay, so you're going to get synonyms and antonyms, but again, because we're using lemmas, which are like synonyms, it's not going to be just synonyms for just the term good, as in good or bad. It's going to be good as in good, good or service, and that kind of stuff. So there's that. Let us, for each step of the way, we can print, let's say, we don't need to do syn for that, because we've seen what WordNet.synSets gives us. But, and then syn lemmas, let's print L here. I'm going to comment this out just so you can see the L. So this will be L colon that. And then synonyms we append. If L dot antonyms, then we're just appending the antonyms. So really the only thing that you haven't seen directly would be syn.lemmas, but of course we have that right here. So this, like syns 0.lemmas, we were taking just the first lemma, but this actually could be a list of lemmas. So we'll do this real quick and hopefully get a list. Right. So these are all of your possible lemmas. Right, so it's a lot of them. Anyway, so that is WordNet up to this point for synonyms, antonyms, all that. I'm going to leave this here now. I'm going to actually get rid of this print statement. We don't need that anymore. And we'll leave these. Now I'm going to create a little bit more space. And then now we're going to talk about similarity. So this will be semantic similarity. So to do that, let's first start with two words. So we're going to have word 1 equals, and word 2 is going to equal something. Word 1 we'll say is wordnet.synset, and we'll use ship, a noun, and we'll just use 0, 1, the first one. There must be one, okay, for a noun for ship. And then for WordNet, we'll say wordnet.synset, and then we'll use boat, noun, in the first one again, just so we know that it's going to be one. Like there may or may not be a boat noun 11, right? But there's definitely a ship or boat 1. So anyway, now what we can do is we can compare the similarity between these two words to find the semantic similarity. So we're going to print, and what we do is print w1.wup, and this stands for Wu and Palmer. And they have Wu and Palmer wrote a paper like early 90s about semantic similarity between words, and this is uses the method that they used. So we'll say wup underscore similarity, and then you compare its similarity to what? So comparing the similarity of word 1 to word 2. and let's just try that one out first. So this will be like a percentage. Right. So they're saying these are 90% basically similar. So now, and I'm sorry, I guess it's not a percentage, it'll be a decimal, where 1 is 100%, and so you multiply this by 100. Anyway, so that's 90% similar. Well, that sounds pretty successful. So let's try a few more. So let's just copy this, paste, and paste. Let's do ship and car, and ship and cat, shall we? Wait for it. Okay, ship and car are 69%, and ship and cat are 32%. That sounds about right, because ship and boat 90% accurate, or 90% similar, or really 91. Why is that? Because they are basically the same thing. Ship and car 69, almost 70% similar, most likely because they're a vehicle, let's say. And then ship and cat, definitely not really that similar, so 32%. That's understandable. Ship and how about a cactus? $38. So a ship is more similar to a cactus than a cat. Makes total sense. Anyway, so that's how you can do some similarity between words if you find yourself needing to do something like that. So what might people use synsets for? And NLTK plus synsets plus maybe word similarity. You can actually use it for two different things. One is to rewrite things. So when you have there's businesses that will, for example, sell you like term papers and stuff for school. So if you have to write a term paper, sometimes you can go online and you can just buy one, right? I'm not advocating for that, but a lot of times what those services are going to do is someone will submit their term paper, and then they use some form of natural language processing, start switching words around. Okay, so they take it and they start changing words. That way they can sell this to like 5, 10 kids, and they have hopefully a different paper. But then what the other people can do is the schools can come by, read the paper, and then use the exact same methodology, only reversed, to find out who has been just simply switching words around. So they can use similarity to figure out, are people just switching synonyms and stuff like this, or the other thing you can do is you can use an antonym, and then you can say not sometimes, depending on what the word is, right? So if it's an action, let's say, you can flip it. Or a description, you could flip it, stuff like that. But anyway, so if you want to catch people who are cheating, or you want to cheat on your term papers, this is probably pretty common. Same thing with like people that write news bots, and where the news bot writes, there's people that make websites that are completely controlled by robots, or not robots, but computers, right? And they write articles, but the way that they write articles is they read other people's articles, they switch a few things around, post up that article, and claim it as their own. So that's another example of how they might do that. And then Google, again, will come through, and at least their goal, I don't think they're very good at it at this point, but they seem to be pretty good at not getting bot websites up. But they can do the exact same opposite and check it against other people's content. Anyway, pretty cool stuff there, pretty simple. The word similarity, I think, is a pretty hard one to write yourself. Synonyms, antonyms, pretty hard. You'd have to build your own WordNet, and why would you? You already have one. And that's about it, I think. The lemmas is useful, obviously. But anyways, a lot of really powerful things that you can do with WordNet. So hopefully you enjoyed. If you have any questions or comments, please feel free to leave them below. Otherwise, as always, thanks for watching. Thanks for all the support and subscriptions. And until next time.